at all. Okay. Uh, so have you been hearing the word agent? It seems to be like the most used word on LinkedIn or like in the tech, at least in SF. I don't know about the East Coast. So yeah, so we don't build agents, but we are like a discovery layer for the agents. So everyone is building agents, right? There are so many frameworks. Like, what are the frameworks you guys heard about for agents? Yeah, that's right. N8N, that's one of them. Yeah, LangChain. And another famous one is Crew AI, if you have heard about it. So these three are like the popular frameworks, but other than these frameworks, there are like so many other frameworks in the market, and people are building agents using all these frameworks. So there should be some place where all these agents should be hosted, right? Hosted, or like they cannot be just like randomly agents. How if people build agents, how will someone use them? There should be, if there is some discovery layer where people can use these agents, then it will be good, so that the person who is building the agent can actually monetize it and do something for by because he built an agent, he should be able to do something. Just like think of it like an app. An app needs an app store, right? So agents, so what we do is we are like we provide the complete ecosystem for all the AI powered services and agents, so that someone can build, and once they build it, others can discover these agents and monetize them. The person who built this agent will monetize them. So we provide the discovery layer for these agents. So that's why we are called search and discovery of AI agents. That's our platform. And so we want to enable an agentic economy. By agentic economy, what I mean is anyone can build their agent, and based on the usage of the agent, they can monetize it. So we have three components. One is ASI1. ASI1 is a discovery layer. It's an LLM. It's an intelligent LLM where it would discover, search, it will enable searching and discovering of agents. And Agentverse is that marketplace. So this ASI1 platform can discover the agents from this marketplace. So that's the idea of ASI1 and Agentverse. And then coming to U agents. So U agents is what enables the agents to be put on the marketplace. So let's say I build an agent with LangChain, someone else built an agent with Crew AI, someone else built an agent with N8N. So all these agents cannot be directly discovered unless there is some communication mechanism that is enabled. So that communication mechanism comes from U agents. So UAgents is the lightweight Python framework, which our proprietary framework. And once any agent is wrapped around this using this UAgents, they are registered on the agentverse. And then once they are registered on the agentverse, all other capabilities come in. So those who guys who came in late, just I'm giving a brief introduction of Fetch. So I'll just repeat it once again. So I hope you heard about agents, right? And by the way, like if someone doesn't know anything about agents at all, uh, yeah, so agent is something like which this is the basic architecture of an agent. It has a model which is an LLM, and it has access to tools. So this model will make some decisions and use the tools in its own way. That's what is an agent. And I was mentioning that these agents, so many people are building agents using different frameworks like LangChain or CrewAI, N8N. And people building agents is not sufficient. There needs to be a layer where all these agents are searched, can be searched and discovered so that people will use them. So we provide that discovery layer. Fetch AI provides that discovery layer, and it is called ASI1. That is the LLM which provides all this. So let's go back. So we have ASI1, the discovery layer, and Agentverse is a marketplace in which the agents are there, and UAgents is a framework using which we register the agents on the marketplace. Now, So this is our tool stack, what we have. Uh, yeah. So we build an agent using UAgent, that is the framework, and then we connect it to the agentverse. I'll tell you what is meant by connecting, and we also deploy it. So, for example, there is no reason that you have to deploy on this agentverse. It's basically we are helping you taking care of the infrastructure, so that you don't have to deploy your agent specifically on your separate VM or infrastructure. We take care of that. All you need to do is just build it, and yeah. So this is the basic architecture. So one is either you can build an agent using UAgent directly. Like for example, when I show you the framework, you'll understand it. You just have to provide the basic logic, and UAgent will take care of things. Or the second way is use the other frameworks like LangChain, CrewAI, AutoGen. When you use other frameworks, you use something called UAgent adapter. It's just another library which we provide so that you can directly register with the agentverse. So the first part of the stack says building an agent. Second part is how do you connect with the agentverse. So I'll better show you in live. Uh, yeah, this is again like repeating what happens internally. So the first point is U agents to agentverse. What happens is when you use U agents, each agent is registered on Almanac. Almanac is like a smart contract on the blockchain. So basically, whenever you use UAgent, it will automatically register on the agentverse. So the only the agents which are registered on this marketplace can talk to each other. That's why we use this framework, because this agent framework will provide capabilities like communication, and it will give its own address. So how do you find an agent? In general, like how do you find someone? You need an address, right? So this agent, to find this agent, it agent gets an address. How it gets an address is through this almanac contract. So whenever the agent registers on the agentverse marketplace, it gets its own specific address, and it is also getting its own wallet. So from this agent address and wallet, other agents are able to find this agent and transact with this agent. That is the basic architecture of this U agents. So far, like anyone is feeling lost, you want to ask questions, feel free. Yeah.
Does this like allow you to like locally run and edit the agents that you find on agent?
Yes. So there are three ways to make an build an agent. One is directly host it on the agentverse. Directly you'll go to agentverse and build it there itself. Like it's like an IDE, basic IDE. But some packages are not supported on that IDE. In that case, what you will do is you'll build it on your local IDE. Yeah.
Two questions.
Sure.
First question is like maybe just to help me understand.
Yeah, yeah.
Can you give like an example of like an actual use case of like an agent being discovered and being used, like an actual customer use?
Yeah.
Walk me through that.
Sure. So let's take a normal LLM. Like let's take a ChatGPT. So on ChatGPT, let's say I want to query some, I'll give some image and ask it to do some prediction on that image. Will ChatGPT be able to do it? ChatGPT is just trained on the entire web, right? It has got no special capabilities. So, but what if you build an agent that is specialized in particular task? Let's say it is specialized in uh, identifying some cancer images. That's it's a specialized model, which is not available on ChatGPT. Now, what ASA1 does is when you go on this ASA1 LLM, you'll query it as, okay, you'll send an image and say, I want to analyze this image for any cancer. And it will go on the marketplace and search for what is the right agent that can perform this task. Once it finds the agent, it will perform the task, execute the task, and give you back the results. So, did you understand the use case?
Yeah. Which leads to my second question. You
Yeah.
mentioned like the cancer image, which
Yeah.
is like PHI, very sensitive information.
Yeah.
How do you ensure that agents that are listed are, it could be pretending to be a cancer analysis agent. The README might say that. but it's actually like stealing cancer images.
Yeah. So for that, we have something called, we are building something called verification. So there is something verified tag will appear for an agent. Only the verified agent can be called. It will not call unverified agents.
Is that verification done by Google?
Sorry? Yeah, verification is done by the fetch team.
Okay.
I have a question maybe about the agent verse.
Yeah.
So I have understood from your example how the ASI1 will work with fetching this right agent for the right task.
Yeah.
But I do not really understand immediately now why storing the registration on a blockchain is the right a database for these agents or like
So this is the marketplace. Agentverse, this is the marketplace. And why registering? So it's like basically blockchain comes in the part where transactions happen. So when transactions are needed, you need some verification, right?
Yeah.
Verification of the transaction and storing of the entire transaction.
Yeah.
That's where blockchain part comes in. So all these agents, this agent was marketplace. This is a centralized marketplace. It's a cloud, but each agent is registered on the blockchain. It's like a registry.
Yeah.
So only the agents that are registered on this decentralized registry, they can talk to each other, communicate each other, and discover each other. Because on the registry, they get its own wallet address.
Yeah, I understand that. I just was wondering what are the advantages of having them on blockchain as compared to, for example, your own private registry that you also only let in some agents, and they will be listed in like in a normal database technology, for example, not the like blockchain technology. Like
So
what are the
yeah,
advantages?
blockchain technology provides that verification capabilities, right? For a when there is a
Well,
decent,
you sign every transaction.
yeah,
For example, like the LLM query that the
yes. Yeah, and when it's a decentralized registry, no one can manipulate this transaction. So, for example, you built an agent that's on the decentralized marketplace, and you can easily claim how many transactions have been taking place with your agent and how many interactions have been taken place and has taken place with your agent. All these are recorded. So, in that case, there is security and privacy involved. That's why the blockchain part.
Oh, and the ledger is like completely public, so people can register their own agents.
Yes, it's an open marketplace.
So all the messages that are in the transactions are encrypted somehow.
Yeah. Yes.
Okay, those are all the questions I have.
Sure.
So, in ASI1, if you have, like, let's say you have two verified agents that have the same use case, how do you guys break ties, or do you guys do evals or something?
Yeah, so there is something called search engine optimization. So each agent you can optimize for the best. So, and after let's say your agent is having more number of interactions, then your agent will be discovered more. And so let's say once first it was you first who built the agent, and someone is already using your agent. So your agent will have a lot of interactions, right? So even after that, if I come and build my agent might not be immediately used because your agent is on the top. And so this guy, I will be trying to compete with you by making a better agent or some better capabilities than yours. And people will, once they use the agent, they will give some ratings to your agent. And that's how my agent will get discount more next because I'll provide some extra capabilities.
Wait, but, that makes sense, but in ASI1, does it automatically pick which agent to use for your use case, or does it just show you which agents
No,
you
so
can
it shows you which agents to
You
use,
can use-
but it will pick the top agent with highest ratings and execute it. But the as a user, I still have the freedom to choose whatever agent I want.
So like, if it picks the top agent every time, then that agent will almost always win in SEO because or like won't their interactions just continue skyrocketing, right? As soon as they.
Yes. That's why there is something called SEO evaluation. You can clearly see for a particular query, for the same query, which other agent is getting picked, what are your competitor agents. That's how you optimize your agent. Yes.
So do you treat the agents as a black box as a user? And you say this is the top rated agent, so I'm going to use this. Do we have any sense of like the cost or the number of calls to reach?
Yeah, you can see all the number of interactions. You can see the agent readme. You can see the number of messages it has got and the ratings it has got.
I mean more in the sense of if it's an agent network, do we know how many agents are within said network? How many tool calls there are? Do we have any sense of that?
The user will not know.
The user does not.
Yeah. Yeah.
Get the ability to like download instances of the agents, or
Sorry.
like do we get the ability to like download?
No, you can't download the instance of agent. You can directly use them. Let's continue with the workshop. We have less time, so I hope I answered at least the basic questions, and no one is feeling lost so far. If anyone is feeling lost, please you can ask the question. We're good? Okay. So this is the marketplace, and this is the ASI one I was talking about. And here what we do is we enable something called agent search here, and then you type your query, it will go and do the uh, remaining part. I'll show you that later. So as I said, this is your first step. You have registered UAgents with the Agentverse, and the second step is Agentverse to ASI1. So this is the ASI1 LLM. It will go and discover, search and discover from this marketplace. Yeah, now building an agent. There are three ways to build an agent. One is hosted UAgent, local UAgent, mailbox agent. So hosted is like what you do is basically you go to Agentverse, then you go to this agents, and then launch an agent. This is launching an agent means if you already have some endpoint, you can directly add it. But here we are creating an agent for the first time. So create an Agentverse. So basically you can choose any one template. Yeah, so this is my agent and this is how the platform looks like. Overview, here is the README. In this part, you will give your best README, like giving all the agent capabilities, what are the example queries, example outputs, and what all things this agent can do. The better the README, the higher chance of discovery of your agent. Then comes the ratings and analytics part. So here, as you see, you can see this agent SEO coach. Here you can see, you can evaluate your agent and see what are the top ranking similar agents that are there related to your agent. And yeah, that is ratings and analytics part. SEO interactions, this is still coming. You can evaluate your agent, and then location is giving your agent a location so that in that particular location, your agent is more discovered. And build part, building is how we build an agent. So I'll give you a brief overview of how you build an agent. So this is the first import. You're importing agent and context. Context is the runtime environment. What the context does is it basically gives all the capabilities of once context is imported, you can enable communication capability. It will give wallet address. It will give how you handle the messages and etc. That is what context does. And agent is just making one instance of the agent after importing. And now after that, we have something called so this context object is also providing this logging of the data and sending of the messages. So agent on event of startup, when we start this agent, I'm starting this agent. As you see, it has received an address. This is the address this agent has got. So through this address, other agents will discover this agent. This address is very unique and it's a encrypted one. That's how we got to the blockchain. And now through this address, other agents will talk to this agent sending messages, receiving messages, and etc. And if you see here overview, you can see this agent address here. This gives the agent address where you can copy the agent address. And if you want to see the fetch that wallet, agent's wallet, this is the wallet of that particular agent. So when this has got funds, this agent will autonomously transact with other agents. So what questions do you have so far in this particular thing? Are we good? Yeah.
So, like, so when the ASI one uses different agents, it needs to pay like big coin or something like crypto to that agent.
Yes.
Is that right?
Yes.
And how does the costs like get chosen? And what happens if the agent doesn't actually do what I wanted it to do? And can I get a refund?
Yeah, all will be happening. So if the agent, so it will be like we are planning after you perform the task based on the ratings, or before the task performance. If the agent doesn't do some particular uh, task as it is promoting, then you'll get a chance to uh, get back the funds.
And who determines whether it's fulfilled by demands?
Sorry.
Like, who makes the decision of whether I'm eligible to request a refund?
Yeah, so that part is still in development. So that completely payment solutions are not yet enabled yet. Yep. This is like the basic building of an agent. Like it's just logging, it's just saying hello, I am agent, and whatever it is logging, whatever it has. Now let's go to little bit advanced agent. With the agent communication. By doing this, I am creating two agents which communicate with each other. One is Alice and another is Bob. So let's go to Alice first. And if we see this build, I hope you're able to see the screen. Now we are adding another thing called model. We are importing, other than agent context, we are also importing model. So by model, what it means is that I have to communicate with some other agent. So the other agent needs to know in what language or what structure I'm communicating, right? This model provides that structure so that it is communicating with this message of string. So that also, that other agent is also expects the same message with the string. If we give it some other model, it will not accept. That is the idea behind this model. Now, what happens is, as we have seen, this we have seen on startup, it will send a message. So sending part is this. If you see this, this is the most important part. So it is ctx.send. It is sending to this agent address. So if you see this 8L, I'll open another instance of agentverse. This is Bob. So if we see the Bob's address, this is 8L. So Alice is trying to send the message to Bob using this address. And it is putting the message under this request. So request is the model. You see this model, right? So it is basically sending this envelope to this to the other agent. Now let's start this agent, and first we need to start both the agents. I'll start this Bob agent so that it can receive the message. And then I'll start Alice agent. Yeah, so message has been sent to Bob, envelope dispatched to the hosted agent. This is Bob's address. And it has also received a message from Bob saying, hello there, Alice, which has been sent by Bob. So it has sent hello there, Alice, and it has received it. Now let's break down what is happening. So this has sent the message to Bob. And what happens is, after it sends the message to Bob, Bob has something called on message. This is called on message handler, agent on message. So what happens is, what on message does is, when it receives a message, what it needs to do. That is what this entire block of code does. When it receives some message, what does agent on message of that particular model, what it needs to do. That is being done by this code block. And then if you see, this Alice also has another block called on message. Why does Alice have this? Because now Bob is sending back the message to Alice, right? Now that's why even Alice needs to have the same code block saying that on message what Alice needs to do. So these are the two important things. One is on startup, what this agent should do, and upon receiving message, what it needs to do. And if you notice, this model and this model are both same because that's the language these both agents are communicating in. So any questions so far? We are good? Yeah.
Is there limitations with merging workflow and remote agents if you want to handle like really low latency tasks?
No, the only limitation is that if you are doing everything locally, the uptime needs to be taken care by you. If it is hosted, it is continuously running. And even if you shut down your system, it is still running. Yeah. Okay, now we have seen one first is the basic agent, and then we have seen how agent communication takes place. Then one last thing we'll see. So there is something called chat protocol. So chat protocol, what it does is it when you enable a chat protocol is nothing but a specification where it will understand natural language processing. Like if you give any query, it basically understands what the query is, and it can uh, so far the U agents what we have seen is they are just basic U agents which has got no intelligence involved. Now with chat protocol, it becomes ASI1 capable. So ASI1 capable means previously the U agents which we built, the two agents which we shown, they are not discoverable by ASI1. So to be discoverable by ASI1, every U agent needs a chat protocol enabled. So when chat protocol is enabled, the ASI1 LLM can discover this agent. So let's see what is chat protocol. So chat protocol is basically a set of standard specifications where it will take in some query, extract some standard parameters, and understand whatever the query is, and it will basically respond back. Like it gives acknowledgement and a response back. That is what is a chat protocol. So what happens when chat protocol is there? Let's see. Let's go to the marketplace. Now these are all so many agents we have. So when an agent has a chat protocol enabled, there is something called chat with agent that appears here directly. So if you see this weather agent, this doesn't have a chat protocol. So this agent is not discoverable on ASI1. So if you go down under the overview and see here, it shows what are the protocols that this agent has. It has health protocol. Health protocol is basically which says whether the agent is running or not, and so it has some other protocol. Let's go to some other agent. Um, let's go to this video generation agent. So this agent has got chat with agent. So this means that this agent has got this chat protocol enabled. You can see, go down here and see this one. So it has got agent chat protocol. So if you click on this, you can see. So this is the protocol that is enabled on this particular agent. So if we enable this protocol, then it means that this agent is discoverable on ASI1. So what happens is it takes a chat message and it basically extracts the parameter from the query and it puts down into a structured output response and then calls the particular function it is trained on. And that's how chat protocol helps in an agent being more intelligent than normal agent. So if you have any questions related to chat protocol, you can ask now. Like if you didn't understand anything about chat protocol. Okay, we'll go ahead then. So as I said, you can enable the agent search here and then ask So while this is going, okay. So as you see, it is saying, I don't have real-time internet access to provide the weather data, but through Fetch AI's agentverse, I can search for a specialized weather agents that can fetch this information. So it is searching for the agents that can do this particular task. So it has found 5 agents, weather agents related to that. So you can directly click here, any of this agent, and use them, or wait for the LLM itself to, it has chosen some agent and it has given the weather for Boston. So it has worked with this particular agent, weather agent. If I see the other agents, these are all the other agents. I hope you understood how the platform works now. So there is one more thing. Here, I didn't know what agent to use, so directly I queried what's the weather in Boston. But what if I know that, let's say I know a friend who built this particular agent and I want to help that, but I want to use only my friend's agent. So what I can do in that case is I'll go to this weather agent, uh, and I copy this address, and directly what I can do is I can directly do like just like how we do in Twitter, at the rate that agent address, and directly ask what's the weather in Boston, and only this agent will respond. In that case, it doesn't need to go and search for the agents and choose a particular agent. So directly I can I don't even need to give this address. I can directly choose this at the rate weather agent, and I can ask weather agent here directly and ask a query. So these are the two ways how I can call a particular agent. Now let's see how much time we have. Okay, we are exactly 9:30. Um, so uh, I've shown you how to make your agent discoverable. So always remember that to make an agent discoverable, it needs an agent chat protocol. And then um, yeah, so I'll just give a brief thing about what this ASI1 does. It is an agentic LLM. By agentic LLM, it can search, discover, rank particular agent for a given task. Then it can do some tool calling. Then it is this ASI, we have an API for this LLM. And this API is OpenAI compatible. So you can make an OpenAI client and just replace it with our own model and API key. And we have got multiple models. Yeah, we have these different models. A7 mini is it is generally for all tasks. Fast is like to get a faster response. Extended is for complicated tasks. And agentic model is like if you want to use search for a particular agent programmatically, you can use this one. And A7 graph is for optimized for data analytics and graphs. And uh, yeah, so these are the basic things. And let me show you a little bit more about the chat protocol. In chat protocol, there is something called, when you enable the chat protocol, these are some things what will happen. So we need to import all these things. So it has like chat acknowledgement. So other agent acknowledges that a message has been sent. Then it has starting of session and ending of session, so that it knows when the session has started with a particular agent and when it needs to end the session. That all that is available. In this, we have shared these entire slides on the Discord channel, Fetch sponsor channel. And this particular slide is very important, the resources slide. It has got the links to each and everything. And yeah, so like definitely go through this one-stop hackathon documentation. That's where you find all the examples, and you can just run through everything. And more importantly, uh, scan this QR code. This will take you to the GitHub repository of all the examples that we have. And one more request is please star this repo so that we'll get more stars and our repo is more visible. Yeah, you can just scan this particular QR code. This one slide is not available on the Discord, but all other slides are available. And the links are anyways available on the slides. Yeah, that's all from the workshop. Sure.
Two questions. One, how do you guys make money?
We are still not making money.
Well, how would you make money?
Yeah, so when you build an agent on our platform, there will be a fee, right? So
Of every interaction.
yeah, not every interaction, like that part still has not been defined, like how we take the cut, but yeah, that's how. And also that's how we make money from developer side. From consumer side, just like ChatGPT, how you make a premium payment, like a monthly premium is there, right? So we could make this ASI one paid subscription part from the consumer side.
And second, what happens when there's no agent in the marketplace that fulfills what you want? Does it force choose one, even though it's suboptimal, or does it come out clean and say like, hey, sorry, I couldn't find any?
Yeah, if it doesn't have any agent particular to particular query, it will not